So I know you guys were falling asleep a little bit and getting tired in class last week, so I'm going to rework the last two on your own problems about density that we did in class. This question was 115. It stated that the density of silver is 10.5 grams per centimeter cubed, and it was made of 0.081 kilograms of silver. They wanted to know what the volume would be. We have our density equation. Density equals mass divided by volume. We know the density. We know the mass. We want to have to solve for volume. These can switch places. You have volume equals mass divided by density. This will be in grams. This will be in grams per milliliter. And then you'll have milliliters on top, and your answer will be in milliliters. Before we get started, we have to get all our units the same. We know that our density is 10.5 grams per centimeter cubed. We discussed it earlier that 1 centimeter cubed is equal to 1 milliliter. So this is also equal to grams per milliliter. And that's what we're going to use for our equation. Now we have 0.081 kilograms. We need grams. So from using that on page 7, we know that 0.081 kilograms times 1,000 grams in a kilogram will give us our answer in grams. Here, kilograms cancel each other out, and we end up with 81 grams. Okay. Now we have, we're solving for volume. We have our mass, 81 grams, and we have our density in 10.5 grams per milliliter. The grams are going to cancel out. The milliliters in the denominator, it's now going to be in the numerator. And we have our answer is going to be 7.7. There's a few more numbers here, but I'm going to tell you why we stop at 7.7. Now we know about significant figures. We have to apply that here now. In our first equation, we had 0.081 kilograms. There's only 2 significant figures in this number. And this one we had 3 significant figures. Your only precise is your least measurement, so we can only go to 2 significant figures. So here, no matter how far we go out, we have to stop at 7.7 milliliters because that is 2 significant figures. If I put 3 significant figures, according to the book, that's wrong. I'll give you half credit for the first couple of tests, but you need to stop at 2 significant figures here because this one only has 2 significant figures. Now let's work the next problem, which is asking you if you found gold. They tell you that the density of gold is 19.3 grams per milliliter. And now it tells you that you have a nugget that's 3.19 kilograms with a volume of 0.065 liters. And they want you to find out if the density of your nugget is if it's gold. Well, this is in grams per milliliter, so we're going to have to get the density of this in grams per milliliter. We don't want kilograms per liter. So the first thing we have to do is take the kilograms. We know there's 1,000 grams in 1 kilogram. Remember, we want it on the bottom so we can cancel each other out, and this is what we want to be left with. So what you want to be left with up top, what you want to cancel out is on the bottom. We canceled them out, and we're left with 319 grams. Same thing, we want milliliters, not liters. So we have 0.065 liters. Well, using page 7, we know that in 1 milliliter, there's 0.001 liters. This is what we want. This is what we want to cancel out. Does it cancel out? Yes, liters cancels out, and we end up with 65 milliliters. Density is mass divided by volume, so it'll be 319 grams divided by 65 milliliters, and our answer will be 4.9. It keeps going. There's some digits here. But again, we got to look at significant figures, grams per milliliter. This number has 2 significant figures because this is a 0. This number, they're all numbers, so I have 3 significant figures. We're only as accurate as our least precise measurement, so that means we can only go to sig figs. So we can only say 4.9. That's as far as we can go out. One significant figure, two significant figure. So the answer is 4.9 grams per milliliter. That does not equal 19.3 grams per milliliter. So our nugget is not gold. We're going to be doing a lot of density measurements this week in class, so be prepared. Thanks.